G'day, I'm Dr. Kev.
And I'm Harley. What have you been up to, Kev? It's been a few weeks.
Just stuff. So before I left, we were doing a little bit of work on the electrics.
Yep. Working with some of the Haltech products, trying to get some of the features integrated into the concept model we've been building.
So if you're not up to date with it, we've got the Haltech R5, which is a ECU, data logger and PDM, which we're pretty excited to use.
And also the UC10 dash.
Yeah, so we've done a previous video on the dash where we looked at how we might set that up, but we actually want to get these communicating on the mock-up.
Yeah, we've been looking at some of the body control features, some of the wiring lengths, how we might terminate things, and a bit of an overall design for the system for bus bars, power distribution, things like that.
Yeah, so I think that was pretty important for us. We haven't really used Haltech products before. I mean, I've mainly used Motec, and you've used a bit of Motec.
Bit of Motec, bit of Mega Squirt, but they tend to be very engine focused, very race car focused applications. Nothing on a entire car, road going car at that level. So it's been a good experience.
Yeah, and I think we're particularly excited with the R5 because it does combine that PDM functionality. We're not using a separate box and we're not actually wiring out to separate relays. So we wanted to use some time to get used to the software as well as how their CAN communications are working between the devices as well.
Yeah, looking at how the ECU integrates with the functions that the UC10 has, how we balance the outputs between the two devices.
Yeah, and also our experience with wiring cars, we've done a little bit on road cars, but probably more experience with the Formula Student cars or Formula SAE cars, or race cars when I was working as a race car engineer. And road cars are different to race cars.
Yeah, there's a bit of differences in say best practice where we might use conduit, say, or heat shrink, and looking at the best way to design that so that we can pull the car apart for repairs if necessary, for example.
And there's a lot more features for road cars. I think road cars, we have to concern ourselves with lights and indicators and body control and whether we're going to have a radio in this and those sorts of electrical systems. So there generally is a little bit more that we need to account for in a road car than in a race car.
Yeah, your pinouts are a lot more complicated. Your body control is a lot more complicated. You've got a lot more power distribution, many more 5-volt, 12-volt sensors. You've got to look at speakers, for example, radio, Dr. Kevin mentioned, headlights, tail lights. It's a lot of things you wouldn't have to normally think about in a car.
Yeah, and I think Project 171 sits somewhere in the middle between a race car and a road car. So we're not going to have everything that you would expect in a road car. A lot of those systems, we may not even have wipers. If the windscreen's low enough, we won't need them. So a lot of those systems we won't have. So we're going to sit somewhere in the middle. And some of those decisions, we just want to have a bit of a play around with. And what would it be like to run this throughout the car, get an idea of what the wiring harness was going to look like.
Yeah, we still want to keep that simplistic mentality happening. So we want to get a bit of an idea on of where the things are going to go and what they're going to do. And if we can remove something that's not required, then we're going to do that.
Yeah, and I think getting this being a little bit more practical, we start to think about all of the different components we're going to use. And you did a big order of wire.
Yeah, yep. TEF cell's very expensive. I'm sure I don't have to tell the audience that, but we found out found that out the hard way recently.
Yeah, and we're actually planning to do what you would do in a lot of motorsport situations where all the wires are actually going to be white. We'll show the colors on the terminal end when we put the connectors, but the actual wires for all the signals will be white throughout the whole harness.
Yep. Utilizing some tagging on either end, of course, to still be identifiable, but that'll be a new one for both Dr. Kevin and I.
Yeah, I mean, keeping your organization of your wiring harness is really important. And I think most of that comes from clear labeling, really. It's very easy, even in a road car where every single wire might be a different different color, different series of lines and so on. It can still get very confusing, even with the wiring diagram chasing which wire you're after. That's where the planning comes into play. So that's why we wanted to do it so early, rather than just wait until the car is together before starting to think about wiring. We wanted to try and address some of those concerns earlier on.
Yeah, trying to figure out that packaging piece a little bit, where you might wanna run wires, where you might have, NVH concerns, getting it all tied in. There's certainly a programming piece as well to consider with the something like the Haltech. That's not something that myself or Dr. Kevin has done before. So getting that all working functionally with switches, it's all a very useful learning experience, and there's certain changes that will come out of the work we're doing now that will find their way onto the final vehicle, 171, and probably be better for it.
Yeah, I think we've been pretty surprised by how good the software for Haltech is. We hadn't used it before, but we found it fairly easy to wrap our heads around. We were able to get things hooked up, not too much difficulty. Probably the most annoying thing would have been the actual wiring and the connectors that they're using on the Haltech.
Terminating pins,
Terminating
classic
pins.
failure.
It's really annoying, and I think we're used to using some of the DT pins. So if we use a DT connector, which is the plan for most of the connectors on the car, it's a really good balance between, I guess, performance and cost.
Simplicity and repeatability for the pins as well on something like a DT connector. Super easy to terminate. Very hard to get wrong unless you're really bad at your job.
Yeah, a lot cheaper than, say, an Autosport connector. And if you've got a set of crimps for that, like these, it's really easy to terminate the ends. You get a really good termination, nice and mechanically secure. The ones that were going in to the Haltech, they were pretty annoying.
Yeah.
That took a lot of time per connector. I think we were looking at about 5 minutes per
Yeah.
connector, basically.
Certainly not a
Per pin.
terrible not a terrible pin if done correctly, but the skill ceiling is much higher, and neither of us are electrical engineers. It seems like the qualification you'd need to pin them correctly.
And I think this is just what we're playing around with. And I think actually, if we can find some of these that can use a better
Round pin.
crimp, so a wet round pin, we're happy to pay the extra money. What's really good, I think, on the R5 is they had these amazing connectors here for the battery connections. Really big fan of these. Nice positive connection. We're going to have to figure out how to crimp the larger battery cables onto these, but I'm sure that's not going to be too much of a problem. But probably don't want to buy the crimpers. I think with these tools, every single one of these crimpers can cost quite a lot of money.
Yeah, we're lucky to have some friends in medium to high places that can assist with things like that where needed.
Yeah, and gave us an opportunity while we're there to play around with some of the different components we're going to be using in the electrical system. So we've got the lights that include sort of high beams, low beams, indicators all in one, and the headlights.
Full tail light set as well. We've got the reverse indicators, hazard lights, brake lights, all integrated into the Haltech functionality.
Yeah, I want to do 4 lights on the back. I'm a big fan of round lights in the 50 style car, but not really happy with the unit that we've got. I think we're going to end up having to do something a little bit custom.
Yeah, PCBs aren't too hard to print these days, so I think we can probably come up with a design and some 3D printed parts to make something that's really nice.
Yeah, while I was away, I spent some time, I got a chance to go to Goodwood, which was fantastic. A lot of resto mods there, and the Chimera in particular had a really nice set of lights. I think they might have been Ferrari tail lights. I don't know that we want to pay Ferrari prices for tail lights, but maybe if we could make something custom like that, it'd be better than what we've currently got.
Yeah, for sure.
So we were playing around with components, and I think the Harley drove this a fair bit because you put together the spreadsheet for all of the pinouts and everything for the wiring harness.
Yeah, so we started with a bit of a length estimation of, sort of what we would require based on the design of 171. That's where our mock-up came in really handy for something like that. So we got a bit of a length together. That helped us to figure out how much TEF cell we were going to need for the order, and then built that into a bit of a basic loom, and we put that on the car, and gives us a good estimate of things like weights and performance, and where we're going to tie in things like bus bars later on for power distribution.
Now we've mocked this up, so some of the wires that we've put in, we've just made them a little bit longer so that we can actually reuse those on the car. Maybe just chop them down, add another
Stuff's
pin to
gold.
them. Yeah, and already I think we didn't order enough wire.
No, we ordered enough for a loom, not for a mock loom and then some. So that's a mistake I'm willing to own.
Yeah, but I think this is a really valuable process for us to go through. And whenever you're doing these sorts of cars, the more things you can think about right at the start of the design are going to really help you as you go through the design, because wiring looms, they don't take zero volume. We've got to put the dash somewhere. We've got to put the ECU somewhere. We've got to run the battery somewhere. And these are all fairly sizable
And they tend
items.
to be a bit of an afterthought. You see on a lot of builds, people build the entire car and then they start thinking about where they're going to put the loom. So things like access holes, like you mentioned, ECU mounting, they tend to be secondary, which can mean suboptimal arrangements and things like wire breakages down the line because you've got a particular fatigue point that wasn't considered. So we're hoping to avoid that.
Yeah, and I think knowing where the wires run, it allows us to do things like strain relief on the wires to ensure that we're not putting any forces on those connectors, but just making that space for them, making the allowance for
Yeah.
it. So I think it was a really valuable thing to do, even though it seems like it's much earlier than you would do this in a project. But if you have been involved with these projects before and you get to the end and you're having issues with wiring, as we certainly have with some of our previous projects, you'll probably appreciate why doing it a little bit early on is well worth the time.
Yeah, and I think more than anything else, and it's an excuse to play with some new toys, and you and I both like that.
Yeah, absolutely. The Haltech stuff's been really great to play with. I'm looking forward to getting something together, and we're aiming now, I think, to try and pick up an engine sometime fairly soon and actually go the next step and have the ECU run an engine on a stand. So it's going to take a little bit of time for us to pull that off, but it is where we're aiming to next after this.
Yeah, for sure. John's going to give us some assistance there, and I'm sure we can con him into a video or two.
Yeah, it should be good. But we've got some questions from viewers. We've got a really good question. It's from one of the videos a bit earlier on. It's from Indonesia01 Ian. I'm a new mechanical engineering student, wants to learn more about chassis, suspension and steering design. Heard that there's software such as MSC Atoms, great software, to simulate vehicle dynamic behavior, but it's expensive. Is there any other way for us to evaluate our design? Would love to hear from you guys as professionals. How do you get started doing this sort of work?
Yeah, I think as you mentioned, obviously something like MSC Adams Car is a great software, but it's probably, in my opinion, overkill for somebody who's starting out. And this comes in with anything. It could be FEA, for example. You want to start with the basics. You want to understand the topic. So that might be starting with a review and some basic understanding of something like Racecar Vehicle Dynamics. Excellent book to start with.
Going into the books first before you even really
Yeah,
looking
starting
at the
with
tools.
basic kinematics, understanding, weight transfer, tire behavior, that sort of stuff. Even just doing some hand calculations, figuring out
Yeah.
what you would expect from a load transfer perspective. From there, you'd probably jump into something like Excel, right? Put a bit of a spreadsheet together,
Yeah.
model your car. I think it helps you to figure your way through the design process while you're at it. Something like Adam's car, it's all there, it's already figured out. You don't even know the questions necessarily to ask when you're at that stage.
It's an interesting question, because I think when I first started doing this as a student, I jumped into Adam's car before doing any of this. It was a much earlier version because I'm pretty old. But I found it incredibly difficult. You didn't really know what all the inputs were going to be. You didn't really know what all the outputs were going to be. Fantastically capable software and something you want to work towards. And there are some open source variations that are a little bit harder to use than Atoms, but still pretty powerful. I think I would go maybe 3 different paths with this. Is one, I'd be focused on maybe just firing up some CAD software and doing some drawings to understand how mechanisms work. So you mentioned steering. It doesn't take much to set up even a 2D sketch where you can simulate what the steering is going to
Yep.
do.
Basic geometry.
Yeah, and even just a 4-bar linkage with front on. I know that's not how a AA arm system works. They're not a 2D system, but you can learn a lot by looking at them in 2D to start with. And then doing, I guess, a quarter car model. So there's lots of sources on the internet for that.
Something like a MATLAB.
Yeah, MATLAB, or I think you might even find quarter car models as apps. Yeah, and then you're playing with masses, springs, and dampers. And if you understand a quarter car model really well, it's not a huge leap to go to understand what a whole car's doing. You just got the motions, instead of being just a single degree of freedom or 2 degrees of freedom, you just increase that. You go to a 7 degree of freedom model or something like that.
Yep.
But you've got to understand the basics first. And then the third thing that I'd focus on is any research you can do on tires, any reading on tires you could do, looking at the different models for tires. You're never going to waste your time. If you're working with cars, you're never going to waste your time learning about tires. They're both the most basic component on a car, but also the most complicated to calculate around.
Yeah, and I think I'd add a fourth to that list. It'd be just physical testing. You know, Indonesia '01 sounds like he's a mechanical engineering student, perhaps with Formula student aspirations. They've probably got cars that exist. They might even have existing data. Something you could do is look at, say, putting, linear pots on your dampers. You're already gonna have a pretty solid understanding of your spring rates and things on a car that's been built. So getting that physical data, plugging it in, figuring out, is that suspension behaving perhaps the way it does in the model?
If you can't get it happening physically, I think a good simulator does a pretty good job as well. And even some of the games. So things like R Factor 2, I think it's pretty good.
Even a Assetto Corsa.
Yeah, and just have a play around with the different settings, see what they do. And at least then you're getting a bit of a driving experience with it. We just had an interview with Howard at University of Hertfordshire. They run a sim lab there so students can experience that firsthand. Now, since the last Q&A video that we had a video out on the yaw stability of the car in aero, and lots of questions from that, most of which we've answered in the comments. So I guess the general question that summarizes, I guess, all of these style of questions is, how much are we prepared to sacrifice the aesthetics and the original goals of the projects to create a 50s inspired car versus just having straight up performance?
Yeah, I think you've got to think about it from the perspective of the end result. We want a car that drives well and handles well. Um, we also want a car that matches the aesthetic that we're looking for. And I think probably we might end up edging slightly more towards some of the aerodynamic devices that you see in the 60s. I know one user mentioned something like adding air curtains to the front. But again, these are not features that you would start to see on these cars until, sort of 10 years after. But I think probably we will start to edge, a little bit more towards some of those sort of 60s era designs, particularly with the yaw stability question.
Well, one of the viewers had actually made a recommendation of a book, and it was a book about Frank Costin's design. So Frank Costin was doing aerodynamics for the Lotus cars. I actually saw a Costin Nathan car in the Silverstone Museum while I was away. It was I'm not sure it's the prettiest car, but pretty impressive. It was 400 kilo sort of plywood construction. What was interesting in those early years, sort of towards the end of the 50s, the start of the 60s in particular, Frank Costin was dealing with a lot of the issues we're dealing with, which is that those early 50s cars with straight up headlights and so on weren't great aerodynamically. They're somewhat made okay by the fact that the mass is forward. These are front engine cars. When you have some of these yaw stability problems and it's a mid-engine car, then that becomes a lot more of a problem. Given that we've got to actually drive this car and enjoy this car and drive it along highways and so on, I think we're going to have to do some sacrifices to the early 1950s aesthetics. It'll just be a matter of what.
You're limited by what you can do mechanically. I mean, you can increase the polar moment of inertia. You can start to put mass in different places to try and improve that stability. But fundamentally, I think, it's going to come down to aerodynamics.
Yeah, I think some of these are easier pills to swallow than others. I think having the front headlights sort of at least sort of round and upright, but maybe having a cover over them, that probably sits a lot better with me than putting a rear wing on it.
Yeah, I agree with that.
Some of the questions were around how bad is it for some of these cars. I can tell you from first-hand experience, driving that Healy down a highway at 100 k's an hour with a crosswind, it's not great.
Yeah, it's unfortunate we had to throw out the front and rear leaf spring design that we originally.
That was never the option. Well, and look, this is a 1950s inspired car. If we slightly go in towards the 60s where they were solving some of these problems, it's not a huge deal for us. It's still sort of an old sort of British
Yeah.
sports
So
car
we're thinking
vibe.
transverse leafs instead.
There's no leaves. See, we're already going to be running, you know, modern tires. We're going to have modern suspensions. It's already not a 1950s car. I just don't want something that looks like a modern hypercar. As cool as they are, that's just not what we're going for with this car. Now, I think the last question that we address is from Professor Ozone. And it says, like you, I'm interested in road going cars. And the problem that they have is virtually every resource is that they're all centered around race cars. So I guess the question that I'm seeing in here, or the thing is, how do you deal with the fact that a lot of the information out there is focused on race cars and not really on the sort of ICVs or sports cars?
Well, the obvious answer is you watch Car Design Workshop, because that's what we're doing. I think it's a I think it's a in all seriousness, I think it's a good point. It is fairly difficult question to answer. It does kind of come back to fundamentals, in terms of how you start with your design of the car and what you're looking at. So something like suspension travel, you can design your suspension kinematically in the same way you would a race car, to have that extra travel. It's a little bit more difficult, I would say, when you're looking at something like suspension, because you've got to include something like compliance.
Mm.
Bushes aren't a consideration on a
Yeah.
race car. NVH is to a lesser extent a consideration, and that's where something like physical testing helps a little bit. A lot of manufacturers do significant tests on, say, the geometer value of the rubber and work that into the design so that you have acceptable performance whilst maintaining the comfort of the vehicle.
Yeah.
Um, so I'd say there's a lot more considerations, but fundamentally, the design is very similar.
Well, it's very interesting you say there's more race car information, which I think is true. I think when I first started learning this, there was very little available about race cars. So Carroll Smith had written some very good books. There was Race Car Vehicle Dynamics, but there was actually very little out there. And I think one of the things we've seen with Formula Student and Formula SAE is there's been a huge desire for that information, and I think that's contributed to being a lot more published about racing, which has been great to see. There is certainly some information about pure road cars. So if you go through SAE technical papers, you can find quite a lot of information about road cars. I think the difficulty is that it's in that middle region. So there's plenty out there now on race cars and some really good technical discussions, far more vehicle dynamics available there than you could ever dreamed of when I started this. There's definitely stuff about road cars as they'd be manufactured by the big manufacturers, but where it comes to the smaller sports car stuff that sits in the middle, where you may be choosing things like a rose joint, or you may be choosing sort of tough bushes, there's not a lot of information there. It's very hard to come by. And I think, yeah, unfortunately, you've sort of just got to absorb, I think, everything you can from race cars, everything you can from road cars, and then try and make your own call in the middle. Uh, that sort of topic, though, the differences between race cars and road cars, is probably something worth a video in the future. Maybe we could even go through some of the data. So
Look, we'll put it on a list, and maybe something will happen.
maybe very soon. So keep watching this space. This is, of course, of a real interest to us. We've got to build one of these cars. It's not a race car. It's not a road car in the traditional sense. It sort of sits somewhere in the middle. So we're going to keep doing videos about this and keep trying to solve the problems ourselves. So thanks for your time.
Thanks.